So, hello everyone. So we are here for the new challenge ROADEF Euro 2008-2019. So I will present you Quentin Viaud from Saint-Gobain Recherche, and he will present you the new problem for this new challenge.
Okay, thank you, Eric. So this is a challenge organized by Lydia, Tlilane, and myself. So Saint-Gobain is a major and one of the oldest French company. Its total amount of sales is around 40 billions euros, and our main activities are in the habitat market. So we sell products to make home better and increase comfort of our customers. So we are a very innovative company, and to help this effort, we have 8 cross-business R&D centers around the world. We are one of the top 100 global innovators, and this challenge is supported by Saint-Gobain Recherche, which is located near Paris in France. So inside Saint-Gobain Recherche, there are a dedicated applied mathematics team. So we are around 20 engineers. Our mission is to bring value to all Saint-Gobain businesses through the use of operation research, optimizations, data science, virtual reality also. Our main scope is to help sales, marketing, supply chain, industrial process to increase the efficiency of a company. So the challenge here is focused on is a glass problem. So we will focus on Saint-Gobain glass industry, which is one of the major flat glass producer in Europe. So it's the first one in Europe and the second worldwide. Sorry. What we want to develop with in Saint-Gobain glass industry is high value glass materials, or to help comfort in house, or also develop new business opportunity. So how to make glass, for instance, because I guess you can know, but it's always better to have an example. So you are going to put some sand and sodium carbonate and limestone and some other material, for instance, pigments. You are going to put them at high temperature, and you are going to create glass. The idea is the following. So to create glass, you have a 4-step process, so a melting phase. So you will put all your raw materials in a furnace. You are going to burn them up such that it will completely melt. Then you have a fining step. So its main point is to obtain to remove the bubble in the glass. And then you have the last steps, which is a thermal conditioning. So it's to control and to form the glass. So at the end of the float process, you are going to obtain a huge glass ribbon, so glass float, and we are going to cut them in different in what we call jumbos. So jumbos are typically 3 meters per 6 glass panel. So we have some production problem which can arise due to the glass melting. So for instance, sometimes there are air bubbles trapped in the glass, or there are some crack or impacts because we move jumbos from different factories, or they can also have some what we call stone in the glass. So the problem and the subject of this challenge is the following. So we are going to give as input a set of jumbos which may contain defect and a set of glass pieces to cut. These glass pieces to cut are typically used to create double window pane, so and are then sold to you, for instance, in your house. So the idea is to design a set of cutting patterns for the jumbos such that the glass loss is minimal. We have some constraint to ensure, which is that we have to cut all the glass pieces which are ordered by one of our customers. All glass piece has to be defect-free, and we have to respect some cutting and organizational constraint. So this problem is classically a two-dimensional bin packing problem. So, as mentioned, we have two sets of constraints, so one related to the cutting and another one related to the organizational. So, about the cutting constraints, we allow guillotine cuts to be performed. So, it's, as you can see here, it's a guillotine cut is a straight line cut, like this one, which cut a bin from one bin edge to the opposite edge, and it has to be parallel to the other bin edges. So here you have a guillotine pattern, and here you have a non-guillotine pattern. This is mandatory because if you don't perform guillotine cuts, you are going to create cracks on your glass panel, and which highly results in just throwing it away. Due to technical limitation, we also limit the number of cuts which can be performed to obtain a glass piece, so an item. In other words, it means that we bound this number by 3. So on the two patterns present here, they are allowed because on this one you can obtain all the item in 2 cuts. On this one, you obtain all the item in 3 cuts. There are also some extra cutting constraints, so also due to technical limitations, so there's maximum of minimum cut length when can be performed. There are also minimum dimension of waste, and obviously it is forbidden to cut through a defect. So here is an example of the output we are going to give you for the challenge. So we are going to give you a bins which all have the same size and may contain defect, but due to organizational constraints in the industry, those bins are stacked. It means that they are not going to be considered as ordered when you design cutting pattern for them. So for instance, you have to design a cutting pattern for the bin 1, then for the bin 2, and then for the bin 3. You cannot use the bin 3 without having finding a cutting pattern for the bin 1 and bin 2, respectively. Another output is the item we are going to give you to cut. So these items are considered as orders. So some of the items are put in stack, and inside each stack you have a given order on the you have an order on the item you have to cut. So typically this is due to respect production planning. So here is an example of a solution, for instance. So we want you to find a set of cutting patterns to ensure all the cutting constraints and ensuring that the loss is minimal. So here is an example of a solution, ensuring the order. So typically the problem and the subject of this challenge is a two-dimensional bin packing with defects on bin, order on bins, order on item. And each cutting pattern has to be unrestricted, 3-stage, guillotine, and with trimming. And just to give you a quick overview, here's the amount of price we are going to give during the challenge. So the worth total value is 45,000 euros. So if you, and we are going to split them in different sections. And if you want more information, or all of them are available on the ROADEF Challenge website. So thank you.
Thank you.